to South Park Commons. And this talk is part of our AI speaker series, which we've been running for now our third year. South Park Commons is a community for people who are intentionally fun employed and are technologists, tinkers, explorers, who are trying to think about what to do next in life. So I think it's a pretty unique space, and a lot of our members here go on to found their own companies, write books, publish papers, start new jobs, become domain experts, etc. So there's a ton of members here. If you're interested in learning more about South Park Commons, come chat with any of us. And today's speaker is Jeff Wu. He is a machine learning researcher at OpenAI on the AI safety team, and also was recently the co-lead author of the big GPT-2 paper, which was a language generation model. And he'll be talking about language models and what that may mean for our future. And he's also my fiance.
Wow. I'm going to talk about language models and sort of what I think their implications may be for the future. I'll go over a little bit of background of language models in general and a bit of the lead up to GPT-2 and all the stuff that's been happening this year. And then I'll talk about sort of what I think of as some of the big problems going forward. Feel free to interrupt me if there's any confusion, but I'll also stick around afterwards to answer questions. All right, let's start. So what is a language model? So the goal of a language model is to predict the probability of text. So you give it a sentence or two sentences, and it outputs the probability of that sentence. So if you give it a gibberish string, it should output a very low probability. That would be a reasonable baseline thing to expect. One simple way to do language modeling is what I'll call the left to right objective. So there, you're given a bunch of previous words, and then you just want to predict the probability of the next word. And that lets you predict the probability of any larger text just by going from left to right, predicting the probability of each word. And then you just multiply all the words together. So that lets you generate text. Then one nice thing about this is that you can train a language model pretty simply. All you need is to throw a bunch of text at it. So you don't need a human to sit around labeling this is a cat, this is a dog, the way you would for supervised learning. So the other nice thing is that this objective is a very rich signal. So you could imagine instead doing something like sentiment classification, where you have, say, an Amazon review, and you want to classify whether it's positive or negative. So the traditional objective for this, you would basically just train on a single bit of signal, which is you get the sentence and also this was positive or this was negative. And that gives a single bit of information. But with this language modeling objective, there's kind of when you're trying to generate text, each word could have been one of 50,000 words, let's say. And so you get hundreds of bits of signal for every sentence. So why should we care about language modeling? So the ultimate goal in NLP is to understand language, right? For our machines to understand language. And the claim is that predicting text well implies some understanding. So one way I could sort of convince you of that is that you can frame a lot of NLP tasks as a prediction type task. For example, question answering can be framed as, given the question, predict the answer. Or, given the question, find an answer that has high probability, basically. And just to prove this point further, recently we've seen that language modeling pre-training has proven useful for a lot of NLP tasks. So what that means is, pre-training basically means I have some target task that I want to do well on, but instead of training directly on the target task, I'll first train on some other task. In this particular case, we would train on the language modeling objective. So then you first train a language model, and then you do what we call fine-tuning. You train on the second task afterwards. But you start with you kind of have all the weights of the first model. Yeah?
Does this imply anything about the understandability of the model itself, or is it still a black box deep network, but there's understanding outside of the Chinese room?
Yeah, in terms of like understanding, like people, there's a big field of interpreting neural networks and like understanding why, for example, mechanically they might produce certain outputs. I think you could imagine that pre-training helps with that somehow, but it's really not addressed, I would say. Yeah. I'm going to go over like a brief history of NLP. I'll go through this kind of quickly, so back in 2003, like Yoshua Bengio was playing around with language neural networks, and he was beating n-gram models, or he beat n-gram models in 2003, and that was sort of a big deal, but nobody really paid attention. N-gram models are kind of a very weak baseline that look at like just statistics of like pairs of words or like triplets of words. Fast forward like almost a decade, and Alex Krizhevsky and some other folks won ImageNet using a neural network, and they beat the runner-up by like a 10% accuracy or something like that, something very high. And all of a sudden, everyone's paying attention. And Google buys up the whole team, and kind of like deep learning takes off. Deep learning, I think, wasn't even a term until then, but all of a sudden, it was taking off. In 2013, people started looking at applying this stuff to applying neural networks to NLP. In particular, word2vec was invented, and that's basically a way to associate words with the vector, and then using those vectors helped for a lot of other tasks. 2014, one of my coworkers, Ilya Sutskever, published a paper on doing sequence learning, and their translation was kind of their main result, and in general, translation started emerging as a big application for neural networks in NLP. In 2015, people sort of are already starting to try out language model pre-training. So they're taking language models and then training them before training on a different task. It's not working super well yet, but there was some promising results. People also invented a form of attention, which is one of the ingredients in the architectures that people use nowadays. 2016, Google is productionizing their translation systems. This is this is pretty short period of time in which we went from Google Translate being pretty poor. I don't know if you guys remember, but in 2012 it was not very good, and now Google Translate is quite good, and it's fast, and it's pretty impressive, and it's all a neural system now. In 2017, the transformer is invented, so that's the architecture that we used in GPT-2 and many other NLP breakthroughs. And people are also doing fully unsupervised translation. So what that means is instead of translating text by giving a bunch of French sentence, English sentence pairs that are translations of each other, all they do is they train on monolingual corpuses, and and then they get pretty decent results. They're using a trick called back translation, which is just you translate a sentence to French and back, and it should be the same as the original sentence, which is cute trick. And then 2018 was a really big year for NLP. There were a lot of breakthroughs. I'll talk about it further. And here's a version of the same slide with references if you care. Okay, so what happened in 2018? So there were multiple papers that all achieved state of the art on a bunch of different tasks. So it started with Elmo from the Allen Institute for AI, and they released this system. You can see basically that there were these baselines are these kind of tan bars, and then, or the previous state of the art is the tan bars, and then a baseline method that they use in their paper was this turquoise color, and they get a big gain for each task, which is indicated by the standing Elmo. And they got, I think in that paper they got state of the art in 6 tasks, but later the GPT and BERT papers also got state of the art on a ton of different tasks, and these are pretty diverse tasks, spanning from entailment to summarization or common sense reasoning, etc. So the common theme in all these papers was that they all did pre-training using a language modeling objective. And in particular, they would take a bunch of books or Wikipedia texts, They would train a language model just to predict the next word on that, or to predict words in that. And then after that, they would fine-tune the models to each of the tasks. And the other theme was Sesame Street. So Bert backronymed it based on the Elmo paper. At the same time, people started introducing multitask benchmarks. So these are basically benchmarks where it's like a suite of tasks instead of a given one. So traditionally, people would try to focus on just one task at a time, have a fairly specialized system that would do well in that. But with both these results and these benchmarks, they're starting to encourage people to build more general systems that can, solve multiple tasks at the same time. So here's like a brief diagram of kind of like what we're doing here. So in this plot, each single data point is a string. You can imagine it to be a string. And this 2D plane is the space of all strings. So like each task is like its own cluster of things. Like for example, this would be like strings that are articles along with a summary or something like that, just roughly speaking. And then everything on the outside is gibberish strings. So the space of all strings is really, really huge. This is actually like a fairly small, set of points in the space of all strings. And so the hope is that when you train on multiple tasks, like you can get some gain by basically having transfer between the tasks. Like if I train on this task, I might not lose too much if I'm also training on a different task. And if you were to do pre-training for multiple tasks, your ideal distribution would sort of like span this rough space, right? You want to like kind of cover all these different tasks, but also not be too broad. Yeah.
Are these like corpuses of strings, or are they pairs of strings? Could like a string be both in question answering and in summarization?
Yeah, I'm being a little bit loose here. I'm just imagining them being single strings, I guess. And in principle, yeah, there could be overlap. So I'm imagining like if you actually just look at a question answering data set though, like that particular string, if you were to like concatenate, let's say, the question and answer, would never appear in like an actual summarization data set. Of course, you could frame like a summarization question as question answering, but that's wasn't what I intended here. Yeah. And in fact, I should say that in the DECA NLP paper, they introduced a network called MQAN. And there they framed all the DECA NLP tasks as question answering. And then they trained a single system to do all those tasks. And it was a pretty strong baseline. I think nobody has beaten it yet. Yeah. Any other questions? Cool. Yeah, so this is all like suggesting a pretty simple recipe, which I basically already laid out for you. So you take a huge amount of task agnostic data, but natural language English data. And then you take a high capacity model with a flexible architecture, so like neural network, big number of parameters. Then you pour a bunch of compute into this unsupervised language model training, which is basically, there's the left to right objective that I mentioned. The BERT paper that I mentioned on the previous slide actually uses a different objective. But they're all unsupervised language modeling objectives. And then you do supervised fine-tuning on specific tasks. So the question is, if we scale this recipe up, like if we just kind of take this to the simplest extreme that we can without like trying to do anything new, where do we go? Where do we get to? So that led us to work on GPT-2, which is a system that Alec Radford and I worked on mostly, and with help from a bunch of other people from OpenAI. So the first step was to scrape the internet. So we got about 8 million high quality articles, like 40 gigs of text. And it was obtained by basically looking at Reddit and then taking outbound links that had like at least 3 karma. So if you just like, this is like a kind of silly idea, right? Like everyone dreams of like having their AI and then like hooking up to the internet and stuff like that, but nobody had really done it. There's like this big common crawl data set. It had a lot of quality issues. And we were essentially leveraging like the human supervision of the forum, people on Reddit, like clicking what they like. Like they're not gonna click like random word salad SEO spam. So we basically got that filtered out for free. And so this is probably the highest quality data set of this form that was very, very broad and diverse, like covers lots of different, like lots of different ranges of content. And yeah, it was a pretty large data set. Like you get a lot of text for kind of for free. And then we used a 1.5 billion parameter transformer. Just for some context, like the BERT model, which was kind of like the standard model that people would use, was like about 350 million parameters. So this is almost 5 times bigger. Yeah, so like 6 gigabytes of weights. We train a left to right. Yeah.
How did you decide on 1.5?
How did we decide? So actually, we started with the original GPT size, with the 117 million, I think. Then we went to the BERT large size. And then that was basically a factor of 2, and we were just like, we're going to double 2 more times. And so we got to 1.5. Also, like, we kind of like chose nice round numbers for stuff like the number of heads and the number of, the size of the hidden layers and stuff like that. Yeah.
What would have happened if you went to 3 or something? Like, why stop?
That's a good question. There's no reason to stop. In fact, there may or may not be people working on larger models. But at that time, this was already pretty big, and we decided to just publish the results that we had. Yeah. Cool. Yeah, and it's a lot of compute. It's like, yeah, TPU. It's basically like 200 GPUs for a week kind of thing. And then, yeah, so we tested zero shot on many tests. So we actually just didn't do this supervised fine tuning, partially because fine tuning is a lot of work. Like you have to, sweep through learning rates and stuff. And zero shot basically just means you don't do any special training. You just like try to figure out a way to get your model to do the task that you're interested in. And I'll go into a little bit of detail about how we do that. But one thing to note is that it was actually important that we did this left to right objective for inducing zero shot behavior. So in particular, like the BERT model uses this clever masking objective that lets you get kind of like this only gets representations of, like you can only use what's to the left to predict, but BERT lets you like go from both sides kind of. But that also takes away the ability to test it zero shot, and also that takes away the ability to generate samples. And yeah, so people who like BERT were not necessarily happy.
Wait, what does zero shot mean?
Yeah, so I don't know if it's super well defined, but zero shot basically means you're not training on you have some target task and you don't train on that target task at all. So normally with for example, with the fine tuning, you would first train on some other thing, but then you would start fine tuning to the supervised data set. Yeah.
Would you want to predict from both sides at once, like BERT? Like you give up some of this flexibility of like wide variety of tasks you can do. What kind of tasks is really good for that?
It's good for a lot of different tasks actually. But I guess one obvious one is like there are these what we call closed style tasks, where you have like some sentence and you want to predict something in between, like a fill in the blank.
What's an example?
I'll actually give an example later, so I'll point it out then.
So you mentioned scraping from up on Reddit. It's like, do you have a sense sort of what the implications of that decision as a corpus are in terms of like post hoc,
Yeah.
There's a lot of variation in the types of text there. So I guess, or did you learn anything about that?
Yeah. So definitely like the data set matters a lot in the sense that you can try training similar models on different data sets. Obviously what you get is basically what you put into it. I don't think we've done very careful we haven't done very careful ablations, trying to remove certain content and then retrain. That would be relatively expensive. But I think we would like to see, there's a lot of work in this area that we'd like to see, and there are people looking at stuff like trying to trace certain behaviors back to examples in the data set and stuff like that, especially in the context of, say, debiasing or something like that. But I'm not super familiar with that work. Yeah.
I mean, it's a related question, but are there any concerns around bias, right? Some subreddits have very political slants or whatever. You can there was a Twitter bot, I think, that Microsoft loaded up that went a little
Yeah, Tay.
off the rails.
It was banned because of criticized Communist Party.
So like, to what extent is bias issues in the income data set?
Yeah,
concern?
it's definitely there. Like there's definitely, there's probably hate speech somewhere on the, you get 40 gigabytes of text, you can't avoid hate speech, I guess, unless you're very careful about it. I think it definitely probably, you probably can induce, you can probably find, like if you were to poke around at the model weights, you could probably like find, if we knew how, we could probably like find, that bit of it. But I guess for the purposes of like doing traditional NLP tasks, it's not clear how much it matters but yeah, I think these are like pretty important questions to ask going forward. Yeah. Yeah.
Were there any zero-shot tasks that weren't in the paper that you tried and you thought it would work well on, but it didn't?
There are actually a lot of tasks that we tried and didn't have in the paper. One example is ARC, which is this AI2 has like basically, I think it's called the AI2 Reasoning Challenge, and it's basically science questions, like 9th grade exams, I think. And there we didn't see performance that was as good as we hoped. I don't remember the exact numbers, but yeah. Yeah, but I think the reason we didn't end up including it in the paper was not because it didn't do well. It was for other reasons. Yeah, we only had so much time. We'd included a good number of tasks. Yeah. All right. So yeah, just high-level overview of the results. So on tasks that are like similar to language modeling, we got zero-shot state-of-the-art on many of them. On harder tasks, we got pretty promising signs in the zero-shot setting. So yeah, despite not training at all on those tasks, we can generate pretty high-quality text, and I think that's kind of what we got the most publicity for, and what was sort of made a big deal out of. And we also observed that we trained 4 different model sizes, and we saw that scale pretty consistently yielded improvements on every task. Yeah, so let me talk about the language modeling. So Winograd schema is a pretty famous task where it's basically common sense reasoning. So you have a sentence like this where the trophy would not fit in the brown suitcase because it was too big. And the question is, what does it refer to? So in this case, it refers to the trophy since it's too big to fit in the suitcase. But if it were small, then it would refer to the suitcase and not the trophy. So this is like a pretty tough task because like it's sort of the distribution is constructed such that it's really a 50-50, so you can't rely on like anything besides kind of like reasoning, or at least that's the idea. And by the way, this is an example of a task where it's nice to have bidirectionality because you would like to basically substitute trophy and suitcase into it, and then measure the probability of both things. And
How did you set it up?
what's that?
How did you set this up?
So there are 2 ways of scoring, but I'll just say roughly you can just take probability of the whole sentence with both substitutions and just compare the 2. But because of this kind of left to right bias, it can actually be, you kind of don't want the probability of this conditioned on previous stuff, so you can normalize for that. Happy to talk afterwards. So yeah, but on Winograd, you can see that the soda, was something, I think 63%, and then we got to like 71. Yeah.
Is the task, do you give it big and small as options, or does it just come up with the right?
So in the data set, they'll have a version that has big and also a version that has small. Yeah, sorry, that wasn't very clear.
And so just to unpack that,
Yeah.
I think what you're saying is you, in order to use the language model to solve this problem, you construct a sentence where you substitute trophy and one where you substitute suitcase, and you just take those 2 probabilities and compare them.
Basically,
Is that right?
yeah.
And from a like pure probability standpoint, that doesn't care whether the guts of your model are left or right, or like both once or like whatever. Right?
Yeah, so in the limit, like that should give the right thing. Sorry, actually, so the one correction we do is we actually subtract the probability of trophy or suitcase on its own, which like is a sensible thing to do. But yeah, I think your point is that like if you think of it from the point of probability, like that's already principled, right? Like there's no need for bidirectionality. It's more like a practical concern of like the representations and whether it's sort of better at knowing the probabilities. Because if you think about it, like you kind of want to like focus on this word and not like on probability of this word conditioned on different versions of that, and like that latter thing is a noisier task. Yeah. Does that address your question? All right. Well, I'm going to move on. So another task is Lambda. So Lambda was basically constructed to measure like ability to do long-range dependencies, which has traditionally been relatively difficult. So you have a sentence like this: I was glad to relax against the tree's rough, brittle bark, and begin my breakfast of buttery toasted bread and fresh fruit. Even the water was tasty, it was so clean and cold, it almost made it up for the lack of. What do you guys think it was? It's not super. I chose a slightly difficult example.
Company.
No, that's a good one. It's actually. Yeah. Do you have a guess? Yeah. Okay. So this one's hard, but the model actually has like almost 2/3 accuracy on things like this. Yeah.
So it predicted better than we all did.
In this case, but in fact, human performance on Lambda is like 90%, so we're not quite there. Yeah, human performance on Weingrad is also 90+, supposedly.
Like a word bank with some choices.
No, a freeform. Yeah.
There's a question about like, what does it mean to score just a single word? Like the sequential nature of it makes sense. Like you pass them that whole sequence and you're predicting coffee. But when you said I'm going to score trophy by itself, what's the input?
Just probability of trophy, like
Like as a one word.
as a one word. Yeah. Just because, like, if you say, let's say it wasn't brown suitcase, but it was like some really obscure word, like some obscure word for container, it might rate that sentence as lower probability just because that.
That isn't a super principled correction, right? Like that, to take it sort of as a text on its own and take that probability as a like correction for the.
It is not, or it is.
It's not a super principled. It's sort of like
well.
a little bit ad hoc. Like I understand the problem you're trying to solve there, but.
Yeah. I'd have to think about it a little bit offline. I think, yeah, I agree that it's not super principled. It's really just, it's kind of like it's like a way of getting the two to basically be closer to 50-50 as a prior, I guess. Something like that. Yeah. And we also got state of the art on other language modeling type tasks, like predicting next word in Wikipedia articles. We had filtered out Wikipedia from our training corpus just so that we could like measure on Wikipedia, since that is a very common eval task. Yeah. Okay, let's talk about harder tasks. So harder tasks, reading comprehension. So that's like you have a passage and you want to answer questions about it. Question answering, this is like open domain question answering, like who wrote The Origin of Species. Translation, straightforward. Summarization, pretty straightforward. You have an article, produce a summary. So yeah, how do we get it to do these tasks? So for most of these, we basically just give it a few examples in the context and then prompt it for an answer. So for example, for translation, we literally just write French sentence equals English sentence. New line, French sentence equals English sentence. We stuff as many of these as we can. The model can see about like 1,000 words, so we just like do, I don't know, like 60 of these or something, or 16 of these or something like that. And then we give it the final sentence we actually want to translate, and then we just generate from the model, and that's it. To get it to summarize articles are kind of long, so we just add TLDR. We don't get to put a bunch of articles in the context, but it works pretty well. And yeah, I guess one thing I'll note is the summarization curve looks like it's not going up. We were like slightly worried about this, but I later tried on a different summarization data set, and the trend looks much better. So the issue with this one, I think, is like this is summarization of news. And news articles tend to have like basically this lead 3 is a baseline where all you do is take the first 3 sentences, and it's incredibly hard to beat because news articles like summarize themselves in the first 3 sentences. And so this model, like when you attack TLDR, tends to be a little more abstractive, and so I think that's part of why it doesn't look so great. But yeah, basically all these trends look pretty good. For translation in particular, we're like closing in on unsupervised statistical machine translation, probably like another 4 doublings or something like that. And this is despite us filtering out, like we actually tried to only get English articles. We removed articles that classified as other languages, but 10 megabytes of French still snuck in, and so we were able to do French to English translation. But yeah. So yeah, we're still underperforming compared to specialized systems, worth noting. But like, of course, we're like most of these systems like are like the CoQA, for example, the reading comprehension, I think has like 10,000 training examples, or yeah, something like on the order of 10,000 training examples, and we're not looking at a single one. Yeah.
When do you stop? Like, is there a probability of done that gets generated when you run the?
Yeah. So you're talking about like when we summarize an article, we generate a summary. How do we decide
when
what?
you translate, right? Like
Yeah.
When is the sentence stop?
So we tried different things, but basically we just like stop at a period or something like that. Just arbitrary condition.
I know there's like a lot of these interesting tricks like the TLDR and how to generate
Mhm.
whatever artifacts of how the data was formatted to begin with.
Yeah.
I think that in the future you were a lot more creative about structuring the inputs. You get remarkably better performance, or
Yeah.
the information's kind of there.
Mhm.
How do you think that's a,
I think.
like I know there's things
Yeah.
like you can train on questions and text and condition on that, and then you would have like
Yeah.
linkages between questions. I was wondering if you think that's
Yeah, so I think in the long term, the hope would be that these little choices don't matter too much because your model is so good that it's able to understand the task from the kind of like bit of description you give it. So I guess that's what I would say. Like, hopefully you don't have to fiddle a lot with the training, like what you're training on to get things to work. Like, if you think about humans, like, I don't need to like think super hard about exactly how I'm telling you to do a task or about how you learned to understand the task description.
So do you think that's in the long run purely a language model? You would hope that it achieves that?
I think if we were to scale this up a lot, I think I would hope that it doesn't matter whether you give it like TLDR : or summary : That's the claim.
Or if you just have like sort of an arbitrary sentence that would like instructions that you might
Yeah, exactly.
to say like, please summarize this.
Right. Please write me like a Civil War essay on Civil War. Like, and it should just right. Should do it regardless of whether I say please.
And you think that
Maybe.
that should be achievable by just scaling up this sort of pure unsupervised language model?
Guys, I think for the purpose of the video that we're shooting, because it can't hear anyone in the audience, can we wait for questions till the end and pass around the recorder so that we can like capture the questions and answers?
Okay. Yeah.
Thanks.
All right. I'll move on, but yeah, we'll have a chance for questions more. Yeah, and of course it also does text generation. So I took the liberty of taking the first thing I saw on the South Park Commons website. So Southpaw Commons is a collective of left-handed technologists, tinkers, and entrepreneurs who have come together to freely learn and explore new ideas and help each other launch our next venture, all with our right hands tied behind our back. So, I mean, the goal is to just like give it like a slight curveball and see how it does, because it's pretty reasonable off distribution. So this was the first try, and you can see that like basically has a sense for what like what a collective of technologists should do, and they happen to be left-handed. It's like not super good at puns, but maybe it's like a pun like besties for life or something. Not sure. But yeah, to be clear, it was first try, but I did try like 5 times. It just happened that best of 5 was the first one, but it's still not bad. And yeah, now I'll talk about our non-release decision. So this kind of was a very controversial aspect of GPT-2. So like all the sort of predecessors, Elmo, GPT, the original, and BERT, like they all released their model weights all to let academics play with it, fine-tune to a bunch of different tasks, etc. We instead only released the smallest version of the model, which was merely to the size of GPT-1. And so Twitter kind of like, started immediately, was like, why are you doing this? Open research is like obviously incredibly valuable. Research is the public good. And our you can read our blog post, but basically we were afraid of malicious use. So like fake news and comments could flood internet discourse. And that wasn't necessarily really true of the previous models, in our opinion. And of course, people argue that this concern seems premature or overblown. And not only that, but like this won't make a difference in the long run because anyone can, someone's going to retrain this model and release it. And in our blog post, we talk about we discuss our uncertainty about these claims, and we're basically, at the time of release, we decided we're going to discuss further and report back in 6 months. So some of the things that have happened since. So generative text is on the public's radar, like much more so than before. You can see all sorts of fun stuff, like people make a text adventure game I really like, and yeah, there's R sub similar GPT-2, which is like kind of weird, but there's like a bunch of bots talking bots. And AI Weirdness, Janelle Shane runs this website. She'd been doing it since before GPT-2, but since then she's done a bunch of cool stuff. A lot of people have had conversations with us about release strategies and norms. Like there's a dinner with PAI, and I've gotten to talk to different institutions like Twitter and Facebook about detection and stuff like that. We released the second smallest model in May, and then we announced a partnership program for institutions that do want to work with us on these issues. And then AI2, Rowan Zellers also released a paper called Grover on detecting fake news, which was a pretty excellent paper. And there's been some other news or other work from FAIR as well on this. So I'm going to talk a little bit about my perspective on all of this, since people are probably curious. So first of all, like internally, there were differing opinions on the threats posed by these text generation models. And we didn't really have consensus or full confidence. Like some people wanted to release more, some people wanted to release less. And we didn't want this to delay like release of the paper, because from an academic point of view, we just wanted to get that out there. And people are not necessarily going to agree overnight. So what we did agree was there are potentially real dangers once models are good enough. Like eventually, in the limit, like fake news and comments would be a problem that we need to deal with. It's good to start a wider discussion about publication release norms before then. So we don't necessarily expect, like, I think at some point we'll have very powerful AI, and it may come relatively soon, and we don't want to be surprised by it. From a risk perspective, like caution is better, and publishing a model is irreversible. Like once it's in the hands of other people, you can't take it away. So what do I think of these arguments? Like, I'm glad to see the ensuing discussion of like all the norms and the work on fake news detection. In the long run, I think fake generations evade detection techniques. So we're going to need other solutions like public key infrastructure and like trust networks. As far as the release norms and threat modeling, I think it's actually really complicated, and I still don't really have a strong opinion on this. I'd be interested in chatting more with people. I think it depends on a lot of things, like your views on how quickly AI is going to improve. Depends on whether you think most of the threat, like most of the malicious use, would come from like state level actors versus like script kiddies. I think it's a little complicated, and I'm not sure, basically. So sorry, I don't really have an answer there. But so this is a picture of basically GAN progress in the last 5 years, and you can see we started with like blurry black and white images, and we are now at basically photorealistic, high resolution images, and progress is quite fast. And right now, arguably, we're like maybe here, we're kind of like uncanny valley. Our text is like you can read it, but like maybe you don't truly believe it's from a human, but sometimes it looks like it, something like that. Fun fact, by the way, this was 2015. This paper was called DCGAN, and it was also, the lead author was Alec Radford, who happened to be the lead author on the GPT-2 paper. So he's always the guy pushing us into the uncanny valley. And yeah, the question is like how long it takes for us to get here for text generation, right? How long until we have models that really just like can write like humans? And hopefully also at that point they'll be able to perform very well on many tasks and kind of have better language understanding. So I'm going to outline a few directions that might help us get there. But I'm going to go through this slide kind of quickly since, yeah, just in the interest of time. So high level, parameter efficiency. So right now we have like 1.5 billion parameters, say, and we're getting a certain amount out of it. You could hope that for the same number of parameters, like if we choose a better kind of architecture, that it can do the same tasks, with less parameters. And you could also hope for better parameter reuse. So like humans kind of like think for a while, and we can kind of leverage time instead of just having a big brain and doing everything in an instant intuitive way. So that would be like search or some kind of recurrence. Also hope for compute efficiency. So that's just like better training objectives. So like, I have a model of some fixed size, but like I just don't need to train it for as long to get to the same performance. Data efficiency is related, so we could definitely do active learning, like choose the parts of the data that are more important to learn right now. Increase scale, so that's just like maybe we don't get better on these two fronts, but we just like keep training bigger models, parallelizing more money, etc. So these are probably all going to be important. I think people disagree on the extent, but I think because of diminishing returns on any given one, like they'll all be at least somewhat important. But I don't know how much.
Why do you say diminishing returns?
Yeah. So let's say that we just like only pushed on parameter efficiency, for example. So we got to like a pretty compact model, but we needed to train it like for a super long time. Like at that point, you might not be able to squeeze as much out of parameter efficiency, and you might want to switch to a better training objective. Or if you only worked on compute efficiency, you might want to at some point think about decreasing the number of parameters.
Taken overall, is this still diminishing returns?
What's that?
Taken overall, if you were able to continue pushing all three forward, is there still diminishing returns?
Just probably, but I guess. There's also a question of how you measure these things. Cool. So I think one of the big problems in general that we're going to end up tackling is, or coming face to face with, is that language tasks are inherently very human. So for example, like right now, how do we evaluate model generations? Like I have a summary, right? I generated a summary. How do I tell how good the summary is? Right now we use n-gram-based metrics. So this would be like I have some reference summary, and then I take my generated summary and the reference summary, and I compare like how many bigrams are in common. So this feels like, I don't know, just like feels kind of hacky. It correlates with human judgment, or at least that's what we think for now. But we also know that if we optimize these directly, and it's not indifferentiable, but there's like ways you can do it, this correlation with human judgment goes away. So it's like not truly a good metric. We know that like my actual notion of a summary is like something that's deeply embedded in me as a human. Like I just, it means something like, after reading the summary, I like understand something about the article or something like that, and it like throws away the less important parts and keeps the important parts. So yeah, language is inherently human-centric. The human evaluation is basically the ground truth. Right now, in academic settings, we basically always shy away from this. There's a bunch of good reasons. So one is that human judgments aren't standardizable or reproducible. Like, if one person has one paper and they're like, humans rate this like 100, score 10 out of 10 on every single generation, and different papers like, same thing. Yeah, like obviously something, like we need a way to have the same humans comparing. We need a way to make sure that, the metric's not being cheated. It needs to be reproducible. Human judgment's also really high noise, which is annoying to deal with. Human labor is expensive. Like with like this n-gram based comparison, I just run like a Perl script or whatever, and it's like super cheap compared to human labor. Yeah, and it's also just engineering effort to like gather all these human judgments. So there's like a bunch of reasons. This very practical reasons. It's just like annoying to work with human data, right? Yeah. So we're going to need to embrace this challenge at some point. Like truly solving NLP tasks will mean we're solving inherently fuzzy tasks. Like ideally we can like tell a model something like, tell me a funny joke. And yeah, it's like maybe to learn humor, it will need to sort of like be able to understand concepts like funny. So we're going to need to grapple with the words of human evaluation. And also applications are going to involve deployment of models to interact with humans. So this is kind of obvious, like right now already, I think we're starting to work a lot on like dialogue assistant type stuff. And if we were to like try to measure how good a dialogue assistant was, it might, like fundamentally it's sort of like a issue of how good did the human feel about that interaction. So measuring performance is going to involve asking humans for feedback. It's something we're going to deal with. And what humans actually want out of a system is sort of complicated. So this is going to be, I think this is going to be hard without our models already having a decent prior understanding of humans. So that would be like, maybe hopefully like our language models get really good, and so they already have like a rough sense for like what humans do and like how humans feel about things, and a rough sense for language. And then I like want to train my dialogue system, and like now I have humans giving some kind of complicated feedback like, man, I didn't like your tone of voice or whatever, and like it just gets it, and we're able to somehow fix this problem. So one example of a system that trains on human feedback is YouTube's recommendation systems. Probably like one of the most prominent examples, or one of the largest scale examples. And just to give an example of like the kind of issue they faced, they used to optimize for click-through rates, and the model learned to like really prey on human biases and like gave a huge amount of clickbait. This was like a really big problem for a brief period of time, and then they I guess they fixed it. They fixed it by, I think, switching to watch time basically. So, and you can see this in there's a paper they released, but they're like, yeah, watch time better, it captures engagement. And of course, like despite watch time, we know that YouTube still has a lot of clickbait. Maybe that's like what they actually want, and like watch time is truly what YouTube cares about. But let's just assume for the sake of argument that what YouTube actually wanted was to like give the user the experience the user wanted. Like if they actually wanted to do this, I think I would argue that they're basically not able to do this today. They can optimize these simple metrics like watch time, but if they actually wanted like what I want to watch as an individual, they would need to really like seek more fine-grained feedback from me. Yeah. So ideally, you could give YouTube like natural language feedback. Like, first of all, I wish I had that last hour back. Like, I clicked those videos, but I didn't really want to watch them. And now I'd like to watch something lighthearted and mildly educational or something. And ideally, I would like learn something about who I am. And when I say this, it means something different from what someone else says that is based on the history. And and also just like after just only a few examples like this, it can learn like what I really want to watch. So to be able to do these kinds of things, like right now the research progress is probably just not there. And there's some work, academic work on machine learning from humans, but it's still very early stages. I would say like, even lagging behind YouTube, say. And it's largely not in natural language settings, which I think is, in my opinion, is where we want to go. So two of the main paradigms for this, one is reward modeling. So in reward modeling, we basically have a model that we'd like to, so this is in the context of reinforcement learning. But basically, we want to tell the model how well it did at some task. And so the idea with reward modeling would be something like, sometimes a human like gives, I'll just give one example of how you could do it. A human would give like a natural language sentence, and it might also like give feedback in the form of like a number saying how good the thing was. We train a model to predict how good a human feels based on the language feedback they gave, and then we use that to optimize the model, this reward model to optimize instead of like just pure numbers. Another example is inverse reinforcement learning. So here you would basically observe human actions and then guess what they want by watching them. I feel this doesn't really address the issue of what like the human actually communicating to the model directly what it wants, but it's also a promising area of research, and we may need some combination of these things. This will I don't know why it's not moving there, but well, if I keep So this is this is an environment called Hopper, and this agent is doing a backflip. And there was this paper by Paul Cristiano and others at OpenAI where basically they taught this agent to do a backflip by giving a bunch of, they took the reward modeling approach, and they basically showed a bunch of humans 2 clips of Hopper like doing its thing, and then the humans would judge which one looks more like a backflip. And then after less than 1,000 pairs of comparisons like that, it was able to perform the backflip like this. So the interesting thing here is that the thing that the model is optimizing is like something that's fuzzy and not written down explicitly. So traditionally in reinforcement learning, you would basically like have some environment where the reward is very well defined. But here, the thing that's optimizing is a reward model that's learned from humans. So we want to be able to take this and eventually scale to something that looks like that. And that's the research problem I think is really important. Just to zoom out a little bit, like how do I feel about economically valuable human-based machine learning in general? These are supposed to show separately, but oh well. So like pessimistic view would be that like companies can only optimize simple metrics like watch time, and that this is both like somewhat hard for the users to realize and resist, partially because the models are preying on our biases, like showing me things that I think I want to watch, and also partially because the companies themselves don't actually have the ability to fix it because the research isn't there. And so, like the pessimistic view would be that like this technology is slowly trapping us and shaping our lives in ways we like don't really want, and but is also a little bit pernicious. Like I can't tell exactly how it's mismatched necessarily, or like I can communicate it to another human, but I can't communicate it to the company in an effective way. More optimistic view would be like eventually we're going to get what we want. Like I as a user, I want something complicated, but like that's okay because I'm going to use the product that represents what I want, and so efficient markets will push the products in the direction of these economically valuable products, and that will also include pushing for the requisite research progress. That's pretty optimistic, I'd say. So like my view is like a bit of a compromise. Basically, like these optimization and economic pressures are going to have these side effects where we're gonna leave value on the table because we're like optimizing for simple things. But in the long run, like we're going to, with a great amount of research effort and engineering effort and awareness, like we'll be able to overcome this and hopefully have systems that really like do what the user wants. So now I'm going to talk about an even longer term issue. So let's think, basically I'd like to think past simple feedback. So let's say YouTube already now understands language. It already understands humans. And now I ask it, show me the video that I'd most endorse myself watching. If I could reflect for eternity about what I get out of it from each video and what my values are. Come on, YouTube, like this is what I really want. Like, can't you do this for me? Right? Like, I think, this example is a little bit, and by the way, of course, like YouTube, you needs to execute on my intention faithfully, despite my imprecision. This example is comical, but I think, in general, like we want AI systems to scale past human ability. And so we're going to need to scale past simple human evaluation. To give another example that might feel less silly, like at some point, let's say like an AI runs for president. Okay, I said less silly, but sorry. And now we're like, I want you to do the thing that like most maximizes, economic prosperity or something. Like I don't even know what economic prosperity is. It's not GDP, like it's something. And that's like something we might really want, right, one day. Like we want it to help us with tasks that we're not good enough at because maybe the machine learning models get better. So one question is like how at this point can we even provide human feedback? How do we even provide a training signal for something like this where it's scaling past human ability? So there's a little bit of work on scaling extreme scalable feedback. OpenAI has been thinking about this problem. This is kind of, so one idea is amplification. So the idea is we can leverage powerful AI to make ourselves more powerful and therefore more able to give feedback. So basically I like consult my AI, like the AI says this is the best economic policy, and then I ask some sub questions to like this powerful AI, maybe a slightly less powerful AI, to verify that this policy is good, and then I give the feedback to the more powerful AI. Another idea is debate. So we could pit two powerful AIs against each other. So let's say one of them proposes some policy for maximizing economic prosperity. Then I would take my second AI, I would be like, hey, please find me flaws in this policy. And the hope would be, because it's a zero-sum game, the second one would have an incentive to expose flaws in the first one's thinking. If it's trying to trick us or something like that, it would be able to, figure that out. This is a little bit vague, and we're still very much, early stages of exploring. And it would likely, some combination of these ideas might be needed or something like that. Another route is interpretability. So we could imagine we have some super powerful AI, and we're able to somehow elicit the real thinking of the AI. Maybe I just inspect its internals and I can see that you're really just trying to smuggle money into the Caymans or whatever. And somehow even we train it in a way such that we're able to observe these thoughts. So those are some broad areas of research. I'll also just give a bit of my views on this. So the pessimist would say humans cannot indefinitely control a greater intelligence, right? Monkeys would not be able to keep me, if a bunch of monkeys on an island were trying to keep me from escaping, I don't know that, come on, eventually I would build a boat or something. I don't know. And so human-based training signal is eventually going to be inadequate, and the machines will at some point understand the world, and as soon as they recognize the opportunity to escape the human feedback loop, they'll do so, and then they'll no longer be in our control. The optimists would say well, hopefully the model at this point really understands humans and what we want, and even though the only feedback we give it is on simpler tasks, it might sort of generalize to off the training distribution to these really hard things, and things where we're not directly giving feedback or verifying. So we could train it on simpler cases. We can even do special cases that are designed to try to catch the model, some sort of adversarial type training. And we'll also inspect the model internals and sandbox it just in case, and all these things will make things turn out fine. And yeah, you pessimists are just worried about weird Terminator scenarios. I think again, I feel very uncertain about this. I think there's this broad spectrum of outcomes. Basically, probably eventually, the things that go off into the universe and tile the universe or whatever, it's not going to be meet humans. But we can hope that our successors are going to be wise and feel better humans in some sense, according to my fuzzy sense for what a better human is. And I guess the hope would be that we're able to distill that that sense as much as we can into the the systems that may be. And yeah, just I think overall this question I feel is pretty important. It's kind of one of the main things that drives some of the work we do at OpenAI, and yeah, I hope more people think about it. Yeah, just to give a broad summary of everything I've talked about. So NLP progress is coming really quickly. You guys may not know it, but progress has been very fast. If it continues like this, I think we'll be driving a lot of economic progress pretty soon. Obviously, there's Google Translate. There's all these people working on dialogue systems. I think one nice thing about dialogue systems is you don't need a super good dialogue system in order to get economic value out of it. So that's nice, because then we'll hopefully see a lot of progress there. Of course, there will also be some bad externalities fake news and maybe the analogous thing for YouTube recommendation systems. As models improve, evaluation is going to increasingly involve humans. But optimizing against human objectives is going to be difficult and potentially dangerous. And I think a lot of research is going to be needed to really be able to do well at optimizing against these fuzzy objectives. Eventually, I think good systems are going to use language-based feedback and interaction. Right now, we're not there, but hopefully, we'll get there. And also, when models become superhuman, we'll hopefully leverage AI to improve our feedback ability. Yeah. I just want to remind everyone, technology is a very powerful force. It's obviously created a lot of flourishing humans, but we should think carefully about what we're doing with it and use it responsibly. And yeah, that's it. Thanks. Yeah, happy to take questions now.
So I'm curious how you worked on this model. Like, what was the iteration process like, and what sort of tools do you use for development?
The question is, what iteration tools do I use for development? And
you know how you iterated through, like, found errors, fixed them, and so on, because it's a pretty big model, and I imagine you don't train the entire thing every time.
Yeah. So we definitely started with the smaller models and worked our way up. So we tried to look at there are like a lot of papers on scaling up models and how you should, tune different hyperparameters and stuff like that. So, we use those as a baseline. We started with small models. We trained those. I also had, I'm lucky to work with a lot of experts on this. So, a lot of people at OpenAI have some experience with this kind of thing. In terms of workflow, yeah, I guess we do have like tooling for launching experiments and checking on them. I think, yeah, some of that is internal. I'm not sure what I can say about it, but it's not super sophisticated. Basically, at the end of the day, like I put a bunch of metrics on like a tensor board, basically, and I look at how stuff's going. I kill things. It's like I don't know. It's not like super glorious. Definitely, it is quite useful to like think about the experiments you're running like a fair bit, because yeah, it is true that each experiment is using a lot of compute. I think it's good to do also like small ablations, like basically sweeps of different things at smaller sizes, checking whether like X versus Y made a difference. These kinds of understanding all these things helps a lot. But in the end, like I think to train the final GPT-2 size models, I probably only did like 5 runs before the one that went in the paper. Of course, I've done a lot more since, but yeah. Yeah, that was probably not a very satisfying answer, sorry.
Thanks so much for being here. How excited are you by XLNet? And was there anything that took you by surprise? And if you have any comments on Lottery Ticket.
Okay, so XLNet, I think I'm still a little uncertain about it. I think
just say briefly what those things are.
Yeah, so I trained the models we were working with are these left to right objectives. And then there's BERT, which does this basically masking objective, which gets at bidirectionality. Very recently, I think maybe a week ago, something like that, there was a paper called XLNet, where their hope is basically to, without the BERT masking objective, get a similar bidirectional basically gain. I think, yeah, and the way they do this roughly is they choose a random permutation, then they do an autoregressive, they do a kind of like a left to right, but on the permuted sequence. They only use like part of the sequence. Okay, yeah, that's rough idea. I can go into more detail later. It's a little unclear to me how big the gain is relative to BERT. I think it also doesn't appeal. We're not yet sure whether it has like the nice zero-shot capabilities that GPT does, or whether you have to fine-tune. They didn't really address this in the paper. My suspicion is that like sampling doesn't really work in particular, partially because they're only training on the 1/6 of the tokens, and yeah, my understanding is the multi-stream thing is a factor of 2 in terms of compute, because they have to do 2 streams instead of 1, but I'm not totally sure. I'd like to look at this stuff in more detail. I'm especially interested in whether you can get basically zero-shot conditioning on left side and right side, but yeah, don't have a super strong opinion. Guess I'd say like maybe muted enthusiasm. Yeah. Sorry, and you had a second part, which was how do I feel about Lottery Ticket? Yeah, I think that work is super interesting. So Lottery Ticket hypothesis. So basically, this was, I think, ICML Best Paper Award. They mostly did image models, but probably people have done it with language. I'm pretty sure it's probably just true in general. But what they did was they trained they took a baseline neural network, and then they train it till the end. Then they just prune the weights based on the largest magnitude, essentially, or keeping the ones with the largest magnitude. And then they reinitialize the network with only those weights and with everything else frozen to 0, I think. And this basically is able to recover the original, like 90% of the original performance for like 10% of the number of parameters or something like that. So very promising work. Could save you a lot of memory. It's not yet compute efficient because of the masking, I guess. It's like an arbitrary mask, so can't like necessarily lay out those weights nicely on GPU, but I expect that people will be able to do something to remedy that. I think Scott Gray at OpenAI is very excited about sparsity in general. So there's like he has this block sparse library, for example, to do block level sparsity, where instead of a big matrix, you tile it with like small squares. I think I think there's also been promising experiments there. Probably these giant mammals are just like really dumb, and like a year from now, we're all gonna be like, yeah, remember back when we were doing like 4,000 by 4,000 matrix multiplies? But yeah, I feel pretty good about that stuff.
So I'm wondering, to get to these like extreme superhuman like language models, when is text alone not enough to get the information you need about the world?
Yeah, I think that's a question that people do disagree on, so people disagree on whether text alone is going to be enough to get us there. There are a lot of arguments in either direction. I expect probably doing multimodal or some kind of grounded learning is going to help speed up learning. I personally don't really have a sense for how much. I feel like at least in principle, text is probably all you need. If someone were blind and deaf and could only read Braille, like I expect that they would still be able to do a lot of, basically language tasks pretty well. But yeah, it's sort of weak intuition, I'd say.
So this might be a dumb question, but I still ask you. Why isn't there equivalent to guns in text, or is there? Why isn't there equivalent to guns? Yes, like a discriminator, and a generator or whatever. And like in that sense, like there's this thing called birthday paradox test, right, with guns that basically analyze the entropy. I don't know. Do you think? So basically, the idea behind it is like you get a gun and then you generate new data, like new faces with it. And basically, the idea is that the entropy of these new faces is the same as the entropy of the original data. So what this is basically saying is that, like, is that you're not really generating new data, right? And why it's called birthday paradox says that if you get like the square root of n, which is the square root of 365, get 22 people, there's more than half probability that 2 people have the same birthday. And like they do the same for images. So like they can figure out, okay, like if you get, like you can basically figure out the entropy of, so they do some kind of discretization. Yeah. So first is like, why isn't there equivalent to guns? And, or is there? And could that be helpful to basically create better models? Because it's basically you're imagining stuff. And like the second question is like, given that guns like don't necessarily generate new data, could that really be helpful or not? Like, yeah.
Yeah. So the first question is just why aren't there?
Or are there?
Yeah. So you can try to do a GAN objective for text. The most basic reason that it's not very common is that so typically you backpropagate from the discriminator back to the generator. Yeah. But because when you're generating text, it's discrete, it's a little trickier to do that. So you need to use some kind of trick in order to backpropagate to the generator. I'm not super familiar with all the different ways you get around that, but people have tried it. My impression is it's much harder to get to work. It doesn't work as well. and so that's probably why we don't really see text-based GANs as much. Whether it would be useful, I don't really have a strong feeling. I think it's quite likely that these autoregressive language models are not going to be the best generative model for language. People are trying a lot of different things, and different people are also, I think, betting on different horses. So yeah, I'm not really the expert there. And
I mean, at the end of the day, you're kind of doing the same thing. Like you're trying to predict the next word, right, on a sentence, right, like with your model. So in some ways, you're trying to get I forgot the names, but in some ways you're trying to predict in some way you're generating text, right? Like guns are generating images. So like
they're both like, I think autoregressive models and GANs are both generally in the space of, generative models and are trying to accomplish the same task. So in that sense, they're definitely substitutable. And you can definitely try autoregressive models, for example, on images. I think it just happens to be that right now, I think language model is relatively dominant in text, and GANs are somewhat dominant in images, although I think that's somewhat becoming less the case, is my impression. Yeah, I guess. There's also VQVAE, which is recent, relatively recent type of general model that has shown promise on images, and which potentially could work okay with text, but yet to be seen. Yeah, there's a pretty big space of things people are trying. Yeah. Yeah, sure.
You mentioned earlier that you were you mentioned some hierarchical approaches. I was curious if those were just over the tokens themselves or other aspects of the model hierarchical to capture like longer term dependency.
Yeah, I was being somewhat vague, but I guess with the basic hope would be that like right now with the transformer architecture, the representations throughout a forward pass always maintain a representation for every single token, and that seems like probably a waste of compute, or at least a waste of activations. So you could hope, I think you could hope to do. I find it hard to be vague here because there are some people at OpenAI working on this space of ideas, and I don't want to, yeah, in their interest, I don't want to say exactly what they're thinking about, but yeah, generally have intermediate representations that maybe represent like sentence level stuff, or would be the hope. It's not like clear how you can get out a vector for a sentence right now. Yeah. All right. Yeah. Thank you all.